Greetings. We are going to find the zeros of this polynomial function. And to do that, I want to use the quadratic technique. So I want to rewrite this in a way so that I force it to look like a quadratic even though it's not a quadratic. So to do that, I want to identify a way to rewrite my exponents here so that I have something squared, something to the first power, and it would be beneficial if I could factor something out of these two coefficients so that it makes the algebra a little easier when we go to use the quadratic formula. So the first thing I'm going to do is I'm going to make a little note about what we're looking for as far as an exponent. So I'm going to rewrite x to the 8th power as x to the 4th power to the 2nd power, and this is a reversal of a exponent rule. And I have x to the 4th power here, so I'm going to be able to have x to the 4th power to the 1st power here if I add parentheses to this, and I'll have x to the 4th power to the 2nd power here when I replace this, so I'll have that quadratic look. I'll have a square and something not squared and then a constant. This works out nice because we have two even exponents here and there is no variable showing here. The next thing I want to do is I want to look for factors of 128 that are actually a square so that I can take the square root of that and have a nicer number out here. And it would also be great if that factor were also a factor of 12. So there are a couple square numbers that we can consider for dividing 128. The first one is 4, and the next one is 16. 16 is the bigger of the two. Let's try that. If we take 128, divide it by 16, we get 8, so that is a square number that will divide this evenly, and so we're going to make use of these numbers. 16, if I take the square root of it, is 4. So looking at 4, I want to determine if 4 divides 12, and it does. That's going to give us another nice integer there. So we have some values that we want to use. So I'm going to rewrite 128 as 8 times 16. And I'm going to use this substitution here. So x to the 4th power to the 2nd power. And then I'm going to rewrite 12 as 3 times 4, x to the 4th power minus 5. And I'm also going to set this equal to 0. Since we are looking for zeros of the function, that means that we are looking for x-intercepts for this expression here. So if we set this equal to 0, we're fixing y at 0, and so we're looking for the x's occurring with a y of 0, so these are x-intercepts. Now that I have this rewrite, I want to do another rewrite. I want to rewrite 16 as something to a 2nd power, and since we've already taken the square root, we know that's 4 to the 2nd power, so this is still 8, this is still x to the 4th to the 2nd, and we're not doing anything else with the rest of this equation, we're just copying it down. So looking at just these two terms here, I have two terms that are to the 2nd power. I'm going to combine them as 4x to the 4th power squared. 8 stays out here, and I'm going to add parentheses here. By associative property, I'm allowed to add parentheses here. And so now this has the quadratic look that I want. This term is squared, this is to the 1st power. These, the 8 and the 3 and the negative 5 are going to be our a, b, and c for the quadratic formula. The 4x to the 4th power is going to be on the left-hand side. So this is the setup we have. Warning, make sure that you bring this negative down with the 5 when you write it. This is negative b as part of the formula out here, so this coefficient here is going to be negative when you write it in. So this is the setup. And we're going to work through a couple steps for simplifying this. We're going to multiply these terms together. Since we have a negative here, that's going to combine with this negative to give us a positive. This is all positive in this determinant here. So at this point, it doesn't look like we're generating a complex number. So are going to end up with a nice square number in here, so it's going to be easy on the calculations that we need to do. All right, as we simplify this, we have 9 is going to be added to the product here. We get 169 here under the square root. This doesn't change. 2 times 8 is 16. So we can take the square root of this now. That's going to give us -3 plus or minus 13 divided by 16. These are two cases. One case where you add 3 to this, the -3 to this. One case where you subtract. And so each of those two cases have to be set equal to this term out here. So we're going to have 4x to the 4th power equals -3 plus 13 divided by 16. And we're also going to have 4x to the 4th power equals -3 minus 13 divided by 16. And so for each of these, we need to solve each of them for x. I've gone ahead and worked through some of the simplification here. So combine these two terms for your numerator, reduce your fraction. Combine these two terms for your numerator and reduce your fraction. So the next thing I want to do is I want to isolate x here. So I'm going to divide by 4 on both sides. So I'm going to have x to the 4th equals 5 divided by 4 times 8 is 24. And then over here, I'm going to have -1/4. And now I want to take the 4th root of each of these. X equals the 4th root, 5 divided by 24. And x is going to equal the 4th root of -1/4. Since these are even roots, we want to make sure that we add a plus or minus out front here. So that shows up as multiple roots here. And then there's simplifications that are possible. But we essentially have 4 different roots showing here. Alright, one rework that I want to show you is this 24 in the denominator can be rewritten if you factor it as 2 to the 4th times 2. And then this is the 4th root, so this is the inverse of this. So we can bring a half out. So if you lose the exponent here because of this inverse operation, you're left with a 2 here in the denominator, so that's really a half. So we can bring a half outside of that root, and we'll have 5 halves left inside. And this is a positive and a negative version of that because of the plus minus here. So this is the 2 real zeros for the original function. And if you would graph this function here, you would see on the graph that it has 2 places where it crosses the x-axis. That's going to be these 2 locations. That means that this other thing here is going to generate complex zeros in the case of the function. If you're looking for just real roots, well, you found those and you can stop at that point. If you have to find more roots, if you're supposed to find all the roots that you can, well, you're going to have to continue to work with this and break it down further. One immediate thing that you can do is set positive and negative versions of this.